Think about the last time you held a simple crayon in your hand. For most of us, it is just a cheap piece of colored wax that we used as kids and then completely forgot about. But if you take a closer look, you will realize that you are actually holding a true miracle of modern engineering. What you probably do not know is that for this tiny object to reach your hand, an ultra-secret network of colossal trains, chemical scientists, and robots moving faster than the speed of sound must work in perfect harmony. Right now, as you watch this video, a single factory hidden away in the United States is pumping out an astonishing 12 million crayons a day. That means 500,000 crayons every single hour, operating without a single pause, every single day of the year. But how does a dark, sticky, and completely dangerous raw material from deep beneath the earth transform into this perfect, smooth, and completely child-safe creative tool? The historical and industrial journey behind this process is far more intense and fascinating than you could ever imagine. If you want to uncover the mind-blowing secrets hidden behind the world's coolest creations, take a quick second to smash that like button and subscribe to the channel right now, because what we are revealing today will completely change the way you look at everyday objects around you. Our story begins long before giant modern machines ever existed, all the way back in the year 1903. Back then, the world was a very gray, industrial place. Workers in massive American shipping yards and train stations needed a heavy-duty tool to mark wooden crates and giant black steel beams. They used large sticks of crude wax mixed with charcoal and heavy, toxic industrial chemicals. These sticks were dangerous to touch for long periods, threw off black smoke if they got warm, and were definitely not safe for kids. That was until two clever American inventors looked at those toxic industrial tools and had a wild, daring idea. They wondered if they could take that same heavy manufacturing technology, strip out the danger, and turn it into something completely non-toxic, vibrant, and fun for kids to use in classrooms. When they released their very first box to the public, it contained only 8 basic colors. Today, the largest factories on Earth can create more than 120 completely distinct shades. But hitting that level of perfection is a total scientific nightmare. If a crayon is just a little bit too hard, it will scratch and tear right through the paper. If it is just a little bit too soft, it will literally melt in your hand before you can even finish your drawing. The secret to solving this massive engineering riddle lies within a mysterious, powerful ingredient called paraffin wax. The journey of paraffin wax begins thousands of feet beneath the ground as a direct byproduct of refining crude oil. When oil is processed to make fuel for some cars and airplanes, a thick, dark substance is left behind. Scientists take this raw leftover and put it through a filtration and purification process so extreme that it completely transforms into a solid, pure white wax that is 100% non-toxic. The most incredible thing about paraffin wax is that it is remarkably cheap to produce in massive quantities. It completely resists water, and it has a unique ability to transfer a perfect layer of color to paper, using nothing but the slight heat generated by the friction of your hand. Because a major factory consumes hundreds of tons of this wax every single week, the logistics network to move it has to be absolutely monumental. This wax does not show up in regular trucks or small boxes. It travels across the United States inside giant, heavily armored railroad tanker cars. Because paraffin wax turns completely solid at room temperature, by the time the train pulls up to the factory gates, the entire shipment looks like a giant, immovable block of ice. If you are loving this journey, make sure to hit that subscribe button right now. To get the solid wax out of these heavily armored train cars, engineers have to use absolute brute force. They hook up high-pressure steam lines directly to the outer metal walls of the train cars. This intense heat works like a giant oven, slowly baking the inside of the tanker until all of that frozen solid wax melts down completely, turning into a piping hot, crystal-clear liquid that flows just like water. Only then do high-powered industrial pumps roar to life, sucking the boiling liquid wax out of the tracks and shooting it straight into colossal storage silos inside the heart of the factory. These silos are so massive that a single one can hold over 100,000 pounds of liquid wax at one time. But the process is only just getting started. With the hot liquid wax safely stored inside the factory silos, the main computer systems take absolute control of the operation. The next step requires surgical precision. The automated system weighs out the exact amount of liquid wax and dumps it into giant, heated mixing vats. This is the moment where color happens. Just. Laboratory technicians add heavily concentrated, fine industrial pigment powders into the mix. These colorful powders can come from rare minerals or advanced synthetic compounds created in labs to ensure the color never fades, even if a drawing sits in the sunlight for decades. But if you only mix regular wax and color together, the final product will be incredibly brittle, rough, and useless. To stop this from happening, scientists stir in a secret formula packed with stabilizers and unique compounds, and the most important one among them is a chemical called stearic acid. Stearic acid is the true invisible hero of this entire manufacturing story. It works directly on the molecular structure of the wax, making it significantly stronger against hard impacts and heavy pressure. On top of that, it gives the finished crayon that beautiful, glossy, and silky smooth finish that everyone recognizes the moment they open a fresh box. But the main job of this acid is actually purely mechanical. It acts exactly like a non-stick cooking spray for heavy machinery. Without it, the hot wax would glue itself permanently to the metal inside the factory and completely destroy millions of dollars worth of equipment. Inside the massive heating vats, giant mechanical blades spin at high speeds, churning and whipping the boiling liquid until the pigment, the wax, and the secret acids transform into a completely smooth, dense, and deeply colorful liquid. Drop a like right now to help this story reach more minds. The moment the colorful liquid mixture reaches the perfect texture and temperature, it is automatically pumped over to the most impressive machine on the entire production line, the continuous rotary molding system. This machine works exactly like a giant amusement park carousel, except it is made of heavy-duty solid steel and spins non-stop. This massive wheel is packed with thousands of high-precision metal molds carved with microscopic accuracy. As the machine turns, automated nozzles pour the boiling, colorful liquid wax directly into the open cavities. This moment is incredibly tense and monitored by advanced sensors, because any air bubble will cause the product to snap. To guarantee that the physical structure of every single crayon is flawless, the filled molds immediately enter a heavy-duty, intensive cooling chamber. Cold water circulates at high speeds around the outside of the metal molds. This shock cooling method forces the liquid wax to solidify uniformly from the inside out, ensuring the crayon becomes completely dense without a single internal crack. As the wax hardens, it shrinks slightly, leaving an uneven layer at the top. That is when a massive, razor-sharp steel blade passes directly over the top of the spinning carousel, scraping off the excess wax and leaving the bottom of every single crayon perfectly flat and clean. This factory is a beautiful example of zero-waste engineering. After a few minutes of intense cooling, the crayons are ready. Mechanical ejector pins push up with serious force, lifting thousands of bright, naked crayons into the air all at once, creating an incredible visual wave of color. Subscribe and turn on that bell. The hard work is not over yet. As soon as they pop out of the molds, robotic arms equipped with soft rubber grippers gently scoop up the crayons and place them onto a conveyor belt moving at blazing speeds. Before they can move an inch further, every single crayon must face a high-stakes test of life or death: the high-speed digital inspection station. Super smart AI cameras analyze every single crayon flying down the belt in less than a millisecond. If the computer detects a tip that is slightly blunt or a microscopic variation in size, a highly precise blast of compressed air fires instantly, shooting the defective crayon clean off the production line. These are recycled back into perfect ones. The flawless crayons that pass the test move straight into the labeling machine, which is easily one of the fastest and most ingenious pieces of hardware in the modern world. Have you ever noticed how hard it is to peel that label? There's a reason. The paper label is not just there to look pretty. It was specifically engineered to be the literal backbone of the crayon. Paraffin wax is still relatively fragile. If you apply force to the bare wax, it will snap. The paper wrapper acts as a tough external shield. Inside the labeling machine, pre-printed sheets of paper are sliced by high-speed blades. As the wax rolls through a spinning drum, a microscopic drop of natural cornstarch glue is applied. The machine then tightly wraps the paper around the wax exactly 2 times. This double layer creates an incredibly high amount of tension that prevents the wax from flexing, allowing a child to press down hard on a table without the crayon fracturing. It's a masterpiece of structural engineering. After being properly dressed in their protective paper armor, the crayons slide into the final stretch: color sorting and packaging. This is easily the most complex part of the factory. The crayons roll down separate lanes into large overhead hopper bins. Depending on the product, the central computer dictates the exact rhythm of the gates. To pack a classic 8-pack, the system releases exactly one of each primary color. For the massive boxes, it coordinates hundreds of lanes simultaneously without a single mistake. At the very end of this massive conveyor line, flat sheets of thick cardboard are grabbed by mechanical claws that instantly fold them into perfect boxes in less than a second. High-speed robotic pushers slide the aligned bundles straight in. Another mechanism folds the top flaps down, seals them tight with thermal hot glue, and uses a laser beam to engrave the specific batch number and production date right onto the side of the packaging. Professional and high speed. The finished individual boxes are then stacked by robotic arms into larger crates, organized onto wooden pallets and wrapped tightly in clear plastic film by a spinning automated arm. The dark, crude byproduct is now a tool of imagination. In just a few short hours, the wax that started its journey as a cold waste product has been purified, colored, tested, wrapped, and boxed, ready to be loaded onto trucks and distributed to stores and schools. It is a flawless cycle of science and automation. Thank you so much for watching. If you have not done it yet, make sure to leave a like, subscribe to the channel, and share this video with a friend. Stay curious, and we will see you in the next episode.